Next up on our discussion on simple circuits, we have series and parallel resistors. There are two basic ways of connecting resistors together in a circuit. We can connect them in series connection, or we can do parallel connection of the resistors, or a combination of the two. When resistors are connected in series, they are connected one after another to form a single line. Let's say we have three resistors, R1, R2, R3. We connect them one after the other to form a single line. These resistors are connected in series. Say that we let a current I to enter the resistors in series. So the current will pass through R1, will pass through R2, and will pass through R3. We have current I1, current I2, and current I3. Ohm's law tells us that if a current passes through a resistor, there's a voltage associated with that. V is equal to I, R. So we have V1 is equal to I1, R1. V2 is equal to R2, I2. And V3 is equal to I3, R3. V1, V2, V3. For resistors in series, the voltages will add up. The total voltage of the resistors in series connection is equal to V1 plus V2 plus V3. The summation of the voltages in each resistor. And since there's only one line, one current, meaning I1, I2, I3, and the total current, I, are all the same. They are equal. I is equal to I1, is equal to I2, is equal to I3. And resistors that are connected in series may be replaced by a single resistance or resistor. The equivalent resistance, R equivalent is equal to R1 plus R2 plus R3. On the other hand, when resistors are connected in parallel, they are connected together such that their endpoints are connected together as shown. These endpoints of the resistors are connected together, and the other endpoints of the resistors are connected together, such that the resistors are literally parallel to each other. If, say, this is point A and this is point B, you have three alternative pathways from A to B. You have pathway 1, and then you have another pathway, and then you have a third pathway from A to B. The resistors are connected in parallel. Say you let a current I enter the resistors in parallel connection. The line branches into 3. The current will also branch into 3. The current will divide into I1, I2, and I3. Total current I is equal to I1 plus I2 plus I3. So, I is equal to I1 plus I2 plus I3. The currents will divide in such a way that the voltages in the resistors will equal. The total voltage of the resistors in parallel, voltage V, is equal to voltage V1 is is equal to V2 is equal to V3. Total voltage V is equal to V1 is equal to V2 is equal to V3. And just like with resistors in series, we can replace the resistors in parallel connection with a single resistance, R equivalent, equivalent resistance. 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And don't forget that this is 1 over R equivalent. The R equivalent is in the denominator. You have to get the inverse to get R equivalent. You have resistors in parallel connection. Ohm's law, EMF sources, resistors in series, and resistors in parallel are enough to analyze most simple circuits. This is particularly true for circuits with only one power source or voltage source. If you see that the circuit has more than one voltage source, that's an indication that you might have to use more powerful analytical tools like Kirchhoff's rules. And that's it for now. That's it for our discussion on series and parallel resistors. We'll continue our discussion on simple circuits in the next video, wherein we will discuss Kirchhoff's rules. So again, that's it for now, and thank you for watching.